welcome to my channel. In this episode, we want to provide an answer to this question. The EduCell Higher Mathematics, January 2019, question number 15 of paper 1. So the total surface area of a solid hemisphere is equal to the curved surface area of a cylinder. That's the criteria given to us. So the radius of the hemisphere is given as r centimeter. The radius of the cylinder is twice the radius of the hemisphere. So given that the ratio of the volume of the hemisphere and that of the volume of the cylinder is in the form 1:m. Let's find the value of m. Meaning after equating the ratio of volume of hemisphere to that of the volume of what? The cylinder. Definitely you get 1:, another value. That value is what we are looking for. So let's begin with the preceding information given to us, which is the total surface area of a hemisphere. So let's quote that by recall. We know total surface area of a hemisphere is given by 3 pi r squared. No, when they say total surface area, we are referring to the curved surface area plus the base area, which will give us 3 pi r squared. Then we are going back to the curved surface area of a cylinder. So let's see, curved surface area of a cylinder is also given by pi r what? H, 2 pi r h. I'm using the capital R because we are told the radius of the two shapes are not the same. Then we can pick it from there. The radius of the hemisphere is given as r, which is what we have indicated. Then the radius of the cylinder is twice. When I say twice, it means 2 times the radius of the hemisphere. So we can see that the r that we are taking as the radius of the cylinder is actually 2 times the radius of the hemisphere, meaning 2r. So meaning if I'm going back into this, I can replace the capital R with the small r, which is in terms of what? Multiplication. So this can further be, okay, curved surface area become 2 pi r, which is 2r and the h. I believe you get that concept. We are replacing the r, which is capital R, with the 2r. So now 2 times 2 will give us 4. So 4 pi r h becomes the curved surface area of the cylinder. So we are done with the first part, I think, up to this. So now why are we writing the total surface area and that of the curved surface area? We are writing this because they are saying that the total surface area of the hemisphere is equal to that of the curved surface area. That simply means that I can equate the total surface area, which is 3 pi r squared, to be equal to 4 pi r h from that same sentence that we are dealing with. The total surface area of the hemisphere equal to that of the curved surface area of the cylinder. All right. So since it's equal, anything that I use to divide here can also divide there. So I can see a common factor of pi r within the two sides. So definitely, since we are saying they are equal, they will cancel out. So I'll be left with only 3r equals to 4h, as in dividing by pi r, both sides by pi r. If you do so, then you are left with this. We are having an r. We have not mentioned anything about the height, but we need a height. So let's represent the height in terms of what? R. By dividing both sides by 4, that gives us h equals to 3 on 4 r. So now we know what the height of the cylinder is. Since we are going to talk of the volume of the cylinder, which make use of the height. Okay, so now let's come back to this side, which is volume of hemisphere. So volume V of a hemisphere volume is given by that formula, which is 2 on 3 pi r cubed. Then let's quote the volume V of cylinder also, which is also pi r square h. Let me replace that with the capital R, which we are working with. And if we are doing that, then this could also be changed back into 2R. The H will also be changed in terms of R by substitution. So let me just go by saying pi times 2R all square times 3 on 4R by substitution, right? We are only replacing the value of capital R with 2R, the value of H with H 3 on 4R. So now let's see how we can do that. This is going to be 2 square times R square, and 2 square will be 4. So I'll be having 4 pi R square times 3 on 4R. Since this is denominator, this is numerator, they can easily cancel, right? And I'm still left with what again? I have R here and R here. This is not in the denominator, it's multiplying. So it will multiply the 3, multiply this to give us R to the power 3. So this becomes 3 pi R to the power 3. So this represents the volume of the cylinder. So now we are now going to equate this with this in form of ratio. So now let's transfer that. We are saying the volume of a hemisphere is to the volume of what? Cylinder. So we are having 2 on 3 pi R cubed is to 3 pi R squared equals to 1 is to m. Okay, so now since it's a ratio, okay, I think this is a power of 3. So let's indicate that power of 3. Since it's a ratio, pi r cubed, when they divide, it will cancel, leaving 2 on 3 as the only thing left is to 3 equals to 1 is to m. We know this is to is a ratio which could be converted into fraction, meaning 2 on 3 divided by 3 equals to 1 divided by m. Ratio converts into a fraction. Then division of fraction, we know we change the division to what? Multiplication, and flip the second fraction. Meaning 2 on 3 times, 1 is here, it goes up over 3, 1 over m. I believe you can multiply. 2, 1, 2. 3 times 3, 9 equals to 1 over m. We are looking for the m, so let's cross multiply. That will give us 2m, this times this, then 1 times 9. But I believe we are looking for the m, so we divide by the coefficient of 2, meaning 2m over 2, 9 over 2, making m to be 9 divided by 2, meaning the ratio of, or the value of m in this expression is just what? 9 divided by 2. I believe you grab the concept. All right. Thank you for watching. Share, like, and comment. Bye-bye.